Hello everyone, this is Anishu, and in this video we will be combining the power of Raspberry Pi and PWM, that is pulse width modulation, to create an intelligent distance detection device. So what is PWM? In this project we will be diving into the world of PWM, a technique used to control the intensity or speed of various components. PWM or pulse width modulation is a commonly used control technique that generates analog signals from digital devices such as microcontrollers. It can be used to control the average voltage supplied to a load such as a motor or LED by rapidly switching it on and off at varying duty cycles. Now, coming to the library that we will be using for this project, we are going to use the GPIO0 library. Let me tell you why we will be using this. GPIO0 is a Python library that provides a high-level interface for working with GPIO pins on Raspberry Pi. It is a great tool for controlling various components including LEDs, buzzers, motors, and much more using simple and intuitive Python code. One of the key reasons that I have used the GPIO0 library is its simplicity and readability. It pretty much abstracts away all the unnecessary details and makes the code much simpler and easier to read, as well as to make. I have studied about the GPIO0 library from its official website. I have searched about the different components that I will be using in this project. By simply searching it in the website, I can see the working of each components given in the website. It is really easy to understand how these individual components work from the examples given in the website. We can simply check each of the objects individually and call these functions by combining them in the code. This will pretty much make our code extremely efficient and will remove all the unnecessary elements from the code. It will also make the code extremely easy to read for anyone who is watching this for the first time. The documentation of the GPIO0 library is freely available in the internet. You can go check it out to create your own projects too. Now it's finally time for the code explanation. We will start by importing the necessary libraries. As you know, we will be using the GPIO0 library, which will allow us to control the ultrasonic sensor, the LED and the buzzer. Also, we will be importing the sleep from the time library to induce sleep durations. Next, we will define the GPIO pin numbers for our components. For instance, we will be using GPIO 23 and 24 for the ultrasonic sensor, GPIO 14 for the LED and GPIO 15 for the buzzer. Next, we will create the object for our components, the ultrasonic sensor, the LED and the buzzer. These objects are instances of the class provided by the GPIO0 library. They make it easier to interact with our hardware. Next, to keep things going, we will print some introductory messages to the console. Finally, let's get to the heart of our project, the main loop. Here we will continuously read the data from the ultrasonic sensor and calculate the LED brightness level based on the distance and play different pitches on the buzzer. Coming to how we are going to do this, we will read the distance using the ultrasonic sensor. Then this value is used to adjust the brightness level of our LED. The closer the object is, the brighter the LED will be. Similarly, the buzzer will also pitch based on the distance measured. The closer the object is, the higher will be the pitch. As the object moves away, the buzzer pitch decreases. This creates a dynamic sound experience. Lastly, we will include the exception handling to ensure a clean exit. If you press Ctrl+C to stop the program, it stops the buzzer and cleans up the GPIO resources, ensuring that everything reset properly. Finally, it is time for the demo. Before diving into the hardware demo, let's understand the circuit diagram that we will be using for this demo. As you can see in the screen, the ultrasonic sensor is connected to the Raspberry Pi through the VCC and the ground pin, as well as the Trig and the Eco pin through GPIO 23 and 24. The LED is connected to the GPIO 14 pin of the Raspberry Pi, and the ground pin of the LED is connected to the ground pin of the Raspberry Pi. Similarly, the buzzer is connected to the GPIO 15 pin of the Raspberry Pi, and the ground pin of the buzzer is connected to the ground pin of the Raspberry Pi. As I increase the distance between the ultrasonic sensor and the object, the LED will slowly start to fade. At the same time, the pitch of the buzzer will decrease. Conversely, if the distance between the ultrasonic sensor and the object decreases, the LED will glow more. At the same time, the pitch of the buzzer will increase. With this, the demo is complete. I hope you enjoyed the video. Thank you.